Hey everybody, it is Tuesday, the 30th of June. The month is almost over. 4th of July is almost here. I thought I would just do a quick video to just kind of go over some of the key concepts for this week in Python. A lot of this stuff, if not all of it, actually should be a review for you guys, but I thought I would go over it anyway. So let me share my screen. This one. Okay. So hopefully you can see that, and we'll just jump right into it. So the first thing is Python rules. This should be review for you. Basically, this is kind of reinforcing the fact that Python is white space sensitive, meaning you have to have the correct indentation. Here's whoops, let's do this. Show you an example of this. So here I have code. None of it is tabbed in, but if I do start tabbing this stuff in, notice my IDE is getting confused. It's like this red squiggly is like, why are you indenting this? It makes no sense. And if I run this, it's going to give me, unexpected indent. Okay, errors. So I have to unindent this like that, and everything should work now. Okay, so whoops, int string. What? Oh yeah, this is failing. That's okay. I can comment that out for now, and this will run. X is not. Oh yeah, that's definitely not going to work. Print there for that. Doink, 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 doink. Dang it, I'm having trouble with this. Okay, there. That'll work finally. Okay, I'll clear this, run it again so you can tell it's nice and clean. Everything's working. I've fixed all the weird stuff. So we'll come back to these two lines of code here in a minute. But for now, I just want to talk about that indentation. Standard indentation is 4 spaces. That's fine. Your IDE is probably already set up with that. You can do a continuation using this character to divide statements anywhere on a line. So if you have a really, really long line of code, you can use this character to kind of like knock it down to the next line without breaking stuff, but that's not very common. Guidelines for comments in Python. We'll talk about this a lot. One thing that it does cover is in this style guide, some of the things we want you to do for sure is include comments at the top of each module. So let's talk about commenting. There we go. Header comments. So at the top of every module, so the top of every python.py file, you should have, the author, an assignment if there actually is an assignment, you say lab 1, lab 2, lab 3, the date, a basic description that explains what the assignment does, what inputs, if any, for the assignment, what outputs, and what sources you may have used. If you guys are using Google or any other resource online, please list it. Okay. I know there are a lot of references in this class and elsewhere about using AI. I want to try to discourage you from using AI to do your homework. But if you end up using it, okay, list it as a source and tell me why you used it and tell me what it changed. So, in other words, you had your code doing X, you looked at AI and it told you to do Y. And if you decide to stick with Y, tell me that in here and say, hey, I used AI. I used Claude, for example, and it told me to do this. I thought that was really cool. Here's why I did it. So using AI for all your assignments is just flat out cheating. But if you're going to use AI a little bit to get something working and you're having a hard time, let me know you did it, right? And I'll give you the benefit of the doubt, unless you're literally just using AI for everything. And then it'll be pretty obvious if you're doing that. So if you have questions about that, let me know. But I know people are going to be using AI per stuff. In fact, your IDE is going to recommend code as you're using it. The IDE has AI built into it. So anyway, for what it's worth. Function comments. We'll talk about functions later, but your function comments we'll talk and we'll need to define what inputs and outputs the function takes. Okay, like this, you would say the function find sum takes A and B as arguments. A is an integer, B is an integer, so on and so forth. Your function comment should tell you what the function is going to return. In this case, it says it'll return the sum of A and B as an integer, something like that. Okay. We'll talk more about comments later, but I just did want to kind of briefly introduce you to that. Okay, that's Python rules. If you have questions, let me know. Variables. Okay. In Python, you can create variables, and Python is not a strongly typed language. By the way, my computer's running really slow. Actually, I don't think it's my computer. I think its desire to learn is running really slow. We'll see what happens here. But anyway, Python is not a strongly typed language, which means when you create a variable to use in your application, you do not have to indicate what data type the variable is. Okay? In many languages, such as Java and C# and C++, when you create a variable, you're absolutely required to indicate what data type is going to be stored in that variable. It's absolutely a requirement in those languages. And then once you have indicated a variable is going to be of a specific data type, you are not able to store any other data in that variable. Okay. That's a strongly typed language. Python is not. So you'll notice when I create a variable in Python, I just say X and I assign it some value. In this case, X equals 5 happens to be an integer, but Python really doesn't care that this is an integer at all. The good part is that for this, in this variable X, I can put anything I want in there. Okay. I'm not restrained by putting integers only, or a floating point number only, or a text or string only. I can put anything I want in there. That's actually really flexible and really nice. It's also problematic because it causes sloppiness in your code. The value inside of X now is very unpredictable, which makes it error prone. And I'll show you some examples of that later on. Variable assignment, the variable is always on the left. The assigned value is always on the right. This assignment, this 5 equals X, that's not a valid operation. That would fail, okay? But you'll see I can assign a string. So to assign a piece of text to a variable, you have to include the text in quotes, okay? Anything within quotes is called a literal string. So Y would have the value hello there, okay, in this case. Let's see. What's happening, you guys should already know this, but what's happening is when you create a variable in Python or in any programming language, what's really happening is memory in RAM inside your computer is being set aside to store data, okay? So in this case, the value X reserves a block in memory somewhere to put data in there while the application is running. When the application stops running, the memory will be released. At least in theory, it should, okay? So the variable, when it creates something in RAM, sets aside a memory address. The memory address is a numeric value represented in hexadecimal. So this is how your computer keeps track of it. It has this hexadecimal, non-human readable memory address, and it'll look something like this, okay? There's no way we can remember that value, right? It's just too unwieldy. That's why we give it an alias. In our case, the alias for this is X. Okay, so X literally is an alias name that points to this hexadecimal memory address, which points into the computer's memory. Okay, so that's what you're doing when you create a variable. Okay, when you assign a value to the variable, you're really stuffing data into that memory location. Okay, so what you can do is, if you're curious, is you can look at the memory address of any variable using the ID function on the variable name. So I could say ID of X, and it would show me where the memory address is, the memory location, as if you would care, but it does. And then if you want it to look like an actual hexadecimal value, you can convert it to hex by wrapping this whole thing, this ID of X, inside the hex function. So it'll actually print it out in hexadecimal like this. Okay. So if you want to fiddle with that, you can. I think it's interesting. It's not something you really need to do or need to even know about too much, but it's interesting to know what's happening in your computer. It's interesting to know what's happening in RAM. It's interesting to know that Python hides all this for you, so you don't have to know this stuff. In other languages, like assembly language, you would have to know what these hexadecimal memory addresses are, and it just gets yucky. Okay, so this is really, really easy in Python. You can run this and try this out in code. It is like 1 in a bazillion chance that you'll get the same hexadecimal memory address as I have. These are going to be pretty much unique to my computer and your computer, but you'll get a value that looks something like this if you run through this little exercise. Okay, I hope that makes sense. Okay, operators. This is also pretty much review. You have arithmetic operators: plus, minus, multiplication, and division. 2 asterisks is raising something to the power. So if I want to raise something to the power of 2, for example, I would say x asterisk asterisk 2 to raise x to the power of 2. The double forward slash for integer will give the whole number only. It won't give the decimal part. Okay. And the percent sign is the mod operator, which will only give you the division, which is exactly the opposite of the integer division sign. Okay. We also have relational operators: less than, greater than, equal to. Okay, which is the double equal sign. The reason it's a double equal sign is because the single equal sign is an assignment. It's not saying, is this equal to that? It's saying, this now absolutely equals this. I'm assigning this new value. So you got to be careful. This can get you in trouble. If you accidentally are trying to do a comparison and you accidentally do an assignment, it will let you do that. We'll talk about that a little bit more throughout the class. But anyway, this is less than or equal to. This is greater than or equal to. And this is not equal to. Okay. We also have logical operators or Boolean operators such as and, not, and or, which we'll also talk about later on in the course. And you probably already have, worked with these, but that's okay. Compound operators in Python are shortcut syntax. So for example, I can say this number, so like let's say I have a variable called num, and I'm going to say num equals num times 2. Okay, so I just want to take the number and I want to make it equal to 2 times the number itself. The shortcut syntax for that is num times equals 2. Okay, so instead of saying num equals num times 2, I can just say num times equal to, and these are functionally equivalent lines of code. This one is just easier to type. This one's easier to read. So I don't care how you prefer to do it. If you want to do the longer syntax and make it easier to read, the shorthand syntax below does not make the code run any faster. The exact same operation under the hood is taking place. Okay. Here's a handful of compound operators and their usage. So you can see what these are doing. If you want to use them, great. Okay. Variable naming. Python's pretty flexible with creating variable names. Um, the rules that Python forces is a variable name has to begin with a letter or an underscore. We will talk about the underscore later on in this course, but for now, you can just assume that a variable name has to begin with a letter or an underscore. A variable name cannot contain spaces. It cannot contain punctuation or any other special characters other than the underscore. Okay. A variable name cannot begin with a number, but it can have numbers in the name. Okay. And a variable name can't be the same as any keyword that's reserved in Python. Okay. And there you can use a good reference book to find out what reserved and keywords are in Python. But as you use Python over the coming years, you're going to start learning what all those Python commands are, and you'll learn pretty quickly that you can't use them for variable names. Okay. There's two different naming styles for variables. So variable names, I encourage you to make them nice and long, okay, so that they're descriptive of their intended purpose. So another person should be able to come to your code and read your code and instantly understand what the variable is being used for. Because of that, a variable name will typically have 2 or 3 words in the name. If you have 2 or 3 words in the name, there's typically in the industry a couple different ways of naming in that case. The first is variable, a word and an underscore and another word. So this is underscore notation. Okay. The other is what's called camel case. Camel case is where you figure typing these underscores is a waste of time. It's just an extra character to type. So instead of doing that, every new word in a variable name, I will just capitalize. The first word will be lowercase. Okay. The first letter will be lowercase. After that, the first letter of each word in the variable name will be uppercase. And the case sensitivity of this is called camel case. So you can do either or. You can use the underscore notation if you prefer it. You can use camel case if you prefer it. Python literally doesn't care. I also don't care as long as you're consistent. I don't want you going through your code and using camel case here and underscore case there and going back and forth. It gets to be confusing. Okay. If you're on a project team making real software in the real world, your team will decide which they prefer to follow, and everybody on the team will eventually agree upon their standard, and then we'll adhere to it. Okay. All right. Here's some of the reserved Python keywords. This is not an exhaustive list, but this is just some examples of them. The word and, the word as, assert, break, class, continue, def, del, elif, else, except, false, finally, true is over here, import. So these are all examples of reserved words. Over time, you will learn more and more and more of these, and you'll learn what you're not going to be able to use for variable names. Okay. Let's see. Functions. There are a lot of functions built into Python. One of the beauties of Python is that it's free and that it's open source. And that also means that millions of developers out there are literally contributing to the Python project. You can literally go to python.org and sign up and become a developer working on the Python code. You can actually write and change and modify Python, and you can submit your changes to GitHub as a change request, and the Python team may accept your change requests and actually make them part of Python itself as it moves forward. That is how Python is evolving, is through this crowdsourcing. So if you want to get in on that, you can. The reason I bring it up is to tell you that there are thousands upon thousands upon thousands of external libraries constantly being created that you can import and use in Python for very specific functions within your industry, like GIS, for example, healthcare, for example, finance, for example, real estate, etc. There's all these external functions that people have already written that you can take advantage of. You can just go to like Google, for example, go to Google right now and type Python GIS libraries or Python GIS functions and things like that. And you can go look them up. And I guarantee you're going to find a ton of stuff out there that's specific to your industry and to your needs. Okay. So I am going to stop right there. I will come back and talk about functions more as we move on. I'll probably do another little video here in a minute or in a little bit. And I also will talk about date functions in a bit. So stay tuned. Thanks.